wonderful color.
Walt Disney presents
The wonderful world of color.
From Walt Disney's Wonderful World of Color, we bring you Searching for Nature's Mysteries. And now your host, Walt Disney.
Ever since the beginning of wisdom, man has been fashioning a brighter light and a stronger glass to help him probe deeper and deeper into the marvels of nature's secret world. Now today, with a modern microscope, we can peer into dark corners we've never seen before. Often we can't explain what we see, but just the looking is always a dramatic and thrilling experience. Now here on this slide is a single drop of water taken from a lily pond. It's a tiny world teeming with life. And here's a closer look at one of nature's simplest creatures, only a step removed from the plants on which it feeds. Adding a camera to the microscope was one of the many techniques we used in filming our motion picture, Secrets of Life. In this true life adventure, we also tell the story of the ant, the bee, and many others. And almost every sequence required a different camera or special lens. But of course, even the finest equipment is valueless without the skill of the men and women behind the cameras. It's the story of these scientist photographers that we're going to bring you on this program. So now let me turn you over to our guide and narrator, Winston Hibler.
The story of nature's secrets of life, as well as the story behind the cameras of our naturalist photographers, begins, as many of our stories do, right here in the research room of our True Life Adventure department. Our staff combed volumes, seeking out material for nature's saga of survival and her methods for continuing her species. But once the material had been selected, the problem was how to get it on film. Well, this was the case in all our True Life adventures. For instance, to film the African lion, we were faced with covering virtually an entire continent. To meet this challenge of space and distance, a special camera truck was designed. This truck became home, darkroom, and mobile blind for our photographer. Atop the truck, a camera tower was installed. From it, impressive scenes of the wildlife of Africa were filmed. Another problem of distance and locale presented itself in filming scenes for the vanishing prairie. The snowmobile made possible travel in the trackless backcountry to photograph buffalo on their winter range. Far out in the mid-Pacific, along the equator, lie the Galapagos Islands. Just getting there was an adventure in itself. 25 days in a 30-foot ketch on the open sea finally brought our photographers to this land of strange animals. Halfway around the globe and far to the south in the Atlantic Ocean lie the windswept, treeless Falkland Islands. Another problem, ocean-wide in scope. But a welcoming committee makes the journey worthwhile. Our worldwide explorations have taken us from southern seas to the top of the globe. In Arctic regions so remote, the photographers had to construct their own quarters in the manner of the native Eskimo. Some of our pictures have presented problems of locale rather than distance. To get close to water birds, a sneak boat is the answer. Lying prone in the boat, the photographer resembles a floating log, and this is exactly the idea. For in this way, he can practically join the bird's family circles. Filming the elusive bighorn sheep was an exercise in mountain climbing. Some of nature's most impressive sights occur under the surface of her waters. But our photographers have devised unique methods of bringing this world to the screen. In preparing a film story of Antarctica, we faced the problem of keeping equipment and photographers functioning at 70 degrees below zero. As you can see, these were problems of time and space and distance. But in filming nature's secrets of life, the problems were just the opposite. Photographing the small, sometimes the infinitesimally small. Now, our research had already told us that there were many stories to be found in nature's secret world. The story of the anglerfish, a fish that has his own built-in fishing pole, complete with bait, which he dangles in front of every passing fish. The marvel is, it works. Amazing stories of the bees and the flowers, and the miracle of pollination. The ingenious method some flowers use for tricking their unsuspecting visitors into spreading pollen. Life in an ant colony, where the rivalry between red ants and black ants is as old as history. The courtship of the comedians of the beach, the fiddler crabs, who lure the ladies with a wave instead of a whistle. And we would investigate secrets of life locked in the tiny seeds, for here are marvels almost beyond belief. To put these stories on film, we knew we would need the aid and advice of the world's finest naturalist photographers, such people as George and Nettie McGinnity. Their book, The Natural History of Marine Animals, is considered an outstanding work. Here in the laboratory of the California Institute of Technology, Professor McGinnity carries on research in the field of photomicrography, adding untold value to biological knowledge. Stuart Jewell has spent many years in the study and photography of plant growth, the marvel of pollination, and the life story of the bee. John Nash Ott, Jr., Dean of Time-Lapse Cinematographers, maintains the most elaborately equipped gallery and camera clinic in the world. His studies in the secrets of plant growth are proving of great benefit in the field of medical photo research. Robert Crandall, graduated as a science major, has devoted his life to an insatiable study and photography of insects. Recognized as an outstanding authority on ants, his research has added immensely to man's knowledge of this insect family. To photograph secrets of life, we knew we must enter many tiny worlds, and so equipment had to be designed and built for the purpose. This was a matter for our veteran staff of technicians. Here is a conventional 16mm camera. It's equipped with a 100-foot film magazine, a 25mm lens, and the standard type viewfinder. This small camera would give our photographers excellent mobility in the field. But to photograph the tiny creatures that were to be our cast of characters, some engineering problems had to be worked out. The camera is modified to accommodate a bellows focusing device, a 3-lens turret, and a different type viewfinder. Then a 150mm lens to achieve the high degree of magnification so essential. Of course, plenty of light. Intense light is imperative. Now for a test subject, a package of matches. Using our high magnification photography and this brilliant beam of light, we can fill the screen with the head of a single match. Well, obviously no creature could live under such a hot light. To solve this problem, a new form of light was developed, a cold light. It's known as a repeating strobe unit. Synchronized with the camera shutter, the light flashes on only for the duration of the exposure, thus avoiding the buildup of intense heat. To cool the strobe unit itself, we use an ordinary vacuum cleaner. Exposed to this cold light for several minutes, the thermometer stands at 75 degrees Fahrenheit. But for final proof, we went to the home of Robert Crandall for some screen tests with a live cast. No heat problem now. The actors don't even get a suntan. Some proved a bit camera shy, but others seemed to enjoy the limelight, or rather the strobe light. In searching for nature's mysteries, Robert and Fanny Crandall turned their living room, dining room, and library into one huge ant colony. Mrs. Crandall is in charge of the feeding. Even the butler's pantry has become a diet kitchen. The ant food is a scientific formula of infant cereal, sugar, and other ingredients. Various species are housed in glass-covered cases, each artificially heated and equipped with a thermometer. Detailed records are kept of ant habits. Rigid schedules are maintained. How and when you feed an ant is just as important as what you feed it. This elaborate ant run, made of plastic tubing, is patterned after their underground tunnels. For watering places, damp sponges provide moisture. Every aspect of their normal life has been considered. There's even a cemetery for the deceased. Now the Crandalls are about to shoot some scenes for Secrets of Life, so it's time to round up the cast. Next, the set is dressed and decorated according to nature's own design. The actors take their places, and the camera rolls. Specially designed equipment, new techniques, and the Crandalls' know-how resulted in these high-magnification scenes of ant life. This teamwork certainly gets the job done, but when they get down to the stretch, it's a tough pull on the guy in the middle. Of course, there's bound to be a sidewalk superintendent. After studying the ant in captivity, the Crandalls took to the field, and they had no trouble locating subjects, for there are over 5,000 different species of ants, each with a specialized story to tell. Only a fraction of ant activity is carried out on the surface. Their most closely guarded secrets are to be found in their subterranean homes. This called for a major excavation. The assistant does the pick and shovel work. The scientist attends to matters better suited to his profession. To keep the ants from moving to a new location, food is stored here in the cellar. A nursing bottle serves as a substitute for the ants' natural food warehouse. Sealed with a pane of glass and a curtain to shut out the light, the ants' privacy is restored. After a few days, the Crandalls return in a hopeful mood. And after the curtain is raised, their hopes are fulfilled. The colony is performing in a normal manner, and photography can proceed. Here, construction crews are hard at work rebuilding tunnels and chambers. How the ants finally outmaneuvered the enemy and blocked its path was only one of the secrets uncovered in the search for nature's mysteries. In the 3 years they spent filming ants, our photographers became personally acquainted with many of their habits. Another amazing secret unlocked by our photographers in their quest for nature's mysteries was found on the sandy beaches of Southern California. Here throughout the spring and summer, people gather in late afternoon awaiting the nocturnal arrival of tiny silvery fish called grunion. With nightfall, bonfires and wiener roasts add a festive note. But when the arrival of the fish is announced, all else is forgotten. By some uncanny instinct, the grunion know precisely when the tide will reach its peak. It is then they come ashore to lay their eggs. Each wave produces more fish and more confusion. The law dictates taking grunion with the bare hands only. It's just as well, too, for the grunion face hazard enough from natural elements. In fact, few species carry out their propagation rituals under more difficult conditions. The female burrows into the sand to lay her eggs. This must be accomplished at the very peak of the tide. Otherwise, the eggs would be washed away by higher waves. The grunion can live only a few moments out of the water, and those who overstay the limit may find themselves left behind to die. A team of naturalist photographers, George and Nettie McGinnity, had often observed this phenomenon. They wanted to delve deeper into the mystery of the grunion, so they came to this beach exactly 2 weeks after the grunion had spawned. The high tides are now due to return and wash the nests away. The McGinnitys wanted to film the effect this will have on the eggs, so samples are gathered for immediate photography. Back at the laboratory, the eggs are carefully studied under the microscope. Now, at the same moment the high tide washes the beaches, these samples are doused with salt water. And there in the microscope is the answer. The action of the salt water proves to be the final magic touch in the process of incubation. The tiny eggs hatch immediately. Outside the laboratory, the surf again assaults the land, and the same waves that gave them birth soon return the tiny fish to the tender cradle of all life, which is the sea. Give him another 1,000,000 years and he may too. Dr. Tilden W. Roberts' training in the field of entomology and biology proved a valuable asset in helping him discover and film nature's secrets. Calling on his knowledge and experiences, he revealed for us the strange story of the diving spider. This tiny creature is actually an air-breathing species. To exist down here, she must have a supply of oxygen. When her work is finally done, this air-conditioned hideout offers shelter and safety for herself and her young. Knowledge of what to look for is a necessity in searching out secrets of life. For instance, the archerfish possesses one of nature's most interesting talents. This fish is an expert marksman and bags his dinner with a drop of water. His eye for fair game certainly isn't limited by size, and apparently he has an exaggerated idea of his firepower. Secrets of life abound in areas all about us, even beneath the waters of an ordinary pond. Here, Merle and Mildred Using employ a unique method in a preliminary search for nature's mysteries. Set in this watertight compartment, the camera can see through the glass window without getting soaked. As the camera box is submerged, a panorama of underwater oddities unfolds. He goes. Merle Dusing's camera explorations produced these and many more startling underwater scenes. What the well-dressed man will wear is sometimes determined by what he's dressing for. Here, Stuart Jewell is preparing for a camera study of bumblebees. In the garden, this innocent little creature minds its own business if you mind yours. But it's a different matter when you invade the privacy of its home. To provide a glimpse inside their underground nest, extreme caution is required. Otherwise, you might stir up trouble, which a bumblebee can supply in alarming proportions. It seems we've arrived just in time for the birth of a bee. Inside the cells, the young are beginning to stir. The bumblebee awakens from its pupa stage full grown. And the first thing it does is eat itself out of house and home. The parent bees have left a cup of nectar. With hunger appeased, it's time for exercise. But at the first attempt to walk, the bumble stumbles. Flat on its back, it rolls out the barrel and has a barrel of fun. Other bees were also studied while searching for nature's mysteries. Honeybees are a necessary agent in pollination, just as pollen itself is a necessity of life to the bee. On her rear legs are pollen baskets, especially designed to carry this golden cargo. When she's loaded with dust, she returns to the hive. The location of the hive is a carefully guarded secret. To find it, several bees are caught in a jar. When enough have been captured, the bees are released, one at a time. Their direction of flight is carefully observed, for their first instinct is to return to the hive. Obviously, whoever made up that idea about following a beeline never tried it. Once out of the field and into the forest, the flight becomes harder to follow. One bee after another had to be released to keep on the trail. This trick of bee tracking was practiced by primitive man, and it still comes in handy. Going visiting without an invitation could result in an uncertain welcome. So, as a precaution, it's probably wise to smell at least as fragrant as the flowers. By following the pollen carriers, we're led to the food storage cells. The growth and development of the egg was an interesting secret of life. But in the cramped quarters of the bee tree, photography was difficult. So a section of the brood comb was removed. It's a delicate operation. If any bees are injured, complete chaos may result. Back at the laboratory, secrets of the bee never before shown on the screen were revealed. Here, our photographer was able to picture the tiny single eggs contained in each cell. The eggs soon hatch into tiny larvae. When they reach the proper size, their cradles are sealed with wax caps. The next step will be the pupa, or long sleep. Normally, this would be a pretty private matter, but by carefully cutting away the walls of the cell, the dormant pupa was revealed. After 13 days of fasting, the pupa comes to life with a flurry and immediately chews herself free. Normally, nursemaids would feed the young bees, but since their home life has been disrupted, a new method had to be found. Drops of honey served on a toothpick proved the answer. Apparently, the bees liked their foster parent, for they soon forsook the toothpick for hand feeding. The bees thrived on the honey, for it's their natural food. But how bees make honey is still one of nature's unsolved mysteries. However, we can view the process. Nectar from the field bees is transferred to the honey makers. Inside their bodies, some mysterious digestive process takes place, converting the nectar into honey. When cured, it will be stored in the honeycomb cells. To witness this spectacle, a small glass section was constructed. The seams are sealed with a melting candle of pure beeswax. With the work finished, a section of the comb is removed to accommodate the window. And now, through this window, we can see the golden liquid being stored. In this way, too, we caught highly magnified close-ups of the pollen packing. The world of the bee abounds with many more fascinating scenes and intriguing mysteries. Stuart Jewell formed an intimate association with the bees. And having made such good friends with the members of his caste, it looks as though he'd have them on his hands from now on. Our search for secrets of life was not confined to the animate creatures of nature's world. It also led us into her vast and bountiful garden. Each flower has the secret of its growth locked in time, amid a process so slow that it can be disclosed only through special camera techniques. Foremost among experts making camera studies of plant growth is John Ott, who has spent years perfecting the technique of time-lapse photography. Time-lapse is a compression of time. The photography goes on 24 hours a day, controlled by a clock. When the hand touches a contact point, lights go on. Daylight is shut out, and a picture is made. Here, Ott demonstrates again. The hand makes contact, lights on, shutters close, cameras click. On each subject, one picture is taken each hour. But when the film is projected on the screen, we see the growth of 24 hours in a single second. Here's a time-lapse picture of cameras taking time-lapse pictures. This movement took place over a period of many weeks. This laboratory houses an amazing variety of growing things, including an orange tree. But an apple tree couldn't be brought into the laboratory, and so to get its secret, it was necessary to move a laboratory into the orchard. With the treetop laboratory installed, a branch from the dormant tree is sealed through the wall. The tiny studio is complete with cameras focused on the branch, lights, and shutters. With the automatic mechanism set, the entire box is tightly sealed. Now, deep in the heart of the tree, the forces that stir all things in spring have sent the life spark coursing through its branches. First, tiny leaf shoots appear. Then buds take shape and suddenly burst into bloom. But this splendor is short-lived, for as beauty passes, the blossom has played out its part in a cycle whose only purpose is new life. At first, the tiny fruit is scarcely visible at the base of the spent flower, but the life force surges in its core. As it swells to maturity, a rhythmic cadence is evident, until at last the full-blown fruit hangs red and ripened on the stem. Foresight and extreme attention to detail account for many cinematic miracles. Looking ahead to spring, John Ott has stored a supply of last winter's snow in the deep freeze. Spread over a flat containing bulbs from Holland, the snow will add the realism of a seasonal change to the spectacle of growth. As the lights melt the snow, the miracle of growth unfolds. Throughout the growing period, the time-lapse cameras keep a constant vigil. Few of nature's ornaments adorn the land more beautifully than her blossoms in spring. And who would not, when summer ends their bloom, call back the daffodil to take a bow? The search for nature's mysteries led our photographers far afield. Here, among the neatly cultivated rows of corn, the camera recorded further evidence of the life force unfolding. The embryo ears send out their silks, the silvery strands beseeching union with the precious germ of life. As if in answer to their plea, the golden tassel blooms, and with windswept extravagance scatters its life-giving pollen. As the germ of life is guided to the kernel, nature's plan is complete, and the life cycle proceeds unbroken. Our camera search continued. In the fields of waving grasses, tiny seeds gave up their secrets to the lens. Here, our photographers filmed evidence of a botanical miracle in the action of the wild oat seed. Sensitive to temperature changes, the awns of the ripened seed bend and turn. Freed by this writhing struggle, they fall to earth. There, as though possessed by some savage self-determination, they push themselves into the soil.